In this video, I'm going to be talking about the fundamental theorem of calculus. Let's assume we have a function which is f of t, and f of t is continuous and then differentiable on a given interval, let's say a and b, where a and b is inclusive. Okay, so let me try and sketch the function. So let's assume that the function looks like this, and then this is the beginning point, which is the interval a, and then this is b, and this is the function y equals f of t. Now you see that in order to find the area, let's assume that there is also another point here which is x, such that x varies between a and then b. In order to find the area that x makes at each point in time is given by the definite integral. Let's say capital F of x equals integral from a to x of the function f of t dt. Now, this function f of x is dependent on the independent variable x. So if x is fixed, then f of x is fixed. If x is variable or it changes, then f of x also changes. Now, according to the fundamental theorem of calculus, if we take the derivative, which is d dx of f of x, then we have to also take the derivative of this side, which is d dx of the integral from a to x of f of t dt. And according to the fundamental theorem of calculus, this is equal to f of t. Now, this is the most, if not important concept in calculus, because it links differential calculus to integral calculus. And in differential calculus, we talk about tangents, but integral calculus, we are talking about areas and volumes. So what this means is that if you take the derivative of an antiderivative of a function, then the result is the function itself. So for example, let's assume that g of x is equal to integral from 0 to x of f of t dt. And then let's assume that f of t is equal to t. Then it implies that g of x is equal to integral from 0 to x of t dt. Now, if we take this integral, then g of x is equal to t squared over 2, evaluated as 0 and x, and therefore g of x is equal to x squared over 2. Now, let's find g prime of x. And g prime of x is the same as 2x over 2. And this is equal to x. Now, you can see some similarities here. F of t is equal to t. And then g prime of x is equal to x. Now, this implies that, so let me write it here. From here, we can see that it implies that g prime of x is equal to f of t. Now, this is the statement of the first part of the fundamental theorem of calculus. And it is very, very, very important to understand this rule. I will later make a video where we can understand in details the concept of this fundamental theorem. Now, what this seeks to say is that anytime you take the derivative of an antiderivative of a function, then the result is the function itself. So let's use this understanding to solve some examples. Find the derivative of the function g of x equals integral from 0 to x of the square root of 1 plus t squared dt. So the function is g of x equals integral of 0 to x of the square root of 1 plus t squared dt. Now, what is g prime of x? G prime of x is d dx of the integral of 0 to x of the square root of 1 plus t squared dt. So now, what we need to do is to say, let f of t to be equal to all of this, which is square root of 1 plus t squared. So therefore, g prime of x is now equal to d dx of the integral of from 0 to x of f of t dt. So let's go ahead and do this integral. Now, remember what we said. We said that capital F of x is equal to integral from 0 to x of f of t dt. So it implies that if we integrate small f of t, we are going to get, capital F of t. So this is capital F of t. So therefore, g prime of x is equal to d dx of capital F of t evaluated at 0 and x. So g prime of x is equal to d dx of capital F of x minus capital F of 0. Now, look at this function. If we insert 0 into this function, you see that we are going to get a constant. It is going to be square root of 1 plus 0 squared, which is 1. Now, if we take the derivative of a constant, you get 0. Now, if we differentiate this capital F of x, remember that by the fundamental theorem of calculus, which is the first part, we established that d dx of capital F of x is equal to small f of x. So therefore, g prime of x is equal to f of x. But remember that we said that f of t is equal to square root of 1 plus t squared. So f of x is just going to be replacing t with x, which is square root of 1 plus x squared. And therefore, g prime of x is equal to square root of 1 plus x squared. Find the derivative of the function integral of from x to x squared square root of t cubed minus 9 dt. So let's say, let h of x to be equal to d dx of integral of x to x squared of the square root of t cubed minus 9 dt. So now, let f of t to be equal to square root of t cubed minus 9. So h of x is equal to d dx from x to x squared of f of t dt. However, according to the fundamental theorem of calculus, if we integrate small f of t, we are going to get capital F of t. So therefore, h of x is equal to d dx of, sorry, d dx of capital F of t evaluated at x and x squared. Now, h of x is equal to d dx of, now you put x squared inside, which is f of x squared minus f of x. Now, let's differentiate the first part. So if you differentiate capital F of x squared, you need to differentiate what is in the bracket. So if you differentiate what is in the bracket, the differential of x squared is 2x. Then you differentiate the whole function. If you differentiate capital F of x, you are going to get small f of x. Then minus, if you differentiate capital F of x, you are going to get, small f of x squared. So here's x squared, and then here's f of x. So this is equal to, now remember that we said f of t equals square root of t cubed minus 9. So what is f of x squared? It is equal to, wherever we see t, we replace it with x. So this is equal to, wherever we see t, we replace it with x squared. X squared exponent 3 minus 9, which is equal to square root of x exponent 6 minus 9. So at the end of the day, h of x is equal to 2x, then f of x squared is square root of x exponent 6 minus 9 minus f of x, and then f of x is equal to square root of x cubed minus 9. So this is the final answer. Find the derivative of the function integral of root x from root x to x of cos theta over theta d theta. So let us let z, capital Z of x, to be equal to d dx of the integral from square root of x to x of cos theta over theta d theta. Then now f of t is equal to cos theta over theta. So it implies that z of x is equal to d dx of the integral from root x to x of small f of t. So here's f of theta. Let's make the correction. So here's f of theta d theta. So now this is equal to d dx of, if you integrate small f of theta, you are going to get capital F of theta evaluated at root x and then x. So let's continue from here. So z of x is equal to f of x minus, so capital Z of x is equal to d dx of f of x, then minus f of square root of x. Now let's do something at the side here. What is d dx of root x? This is the same as d dx of x exponent half, and this is equal to, if you differentiate this, so you bring 1 over 2 down, then x, and subtract 1 from the power, here becomes minus half. So this is equal to minus 1 over 2 root x. So that's the differential of root x. So z of x is equal to, if you differentiate capital F of x, you are going to get small f of x. Now minus, if you differentiate capital F of root x, you need to first differentiate what is inside the bracket. And if you differentiate root x, you are going to get minus, so here's minus 1 over 2 root x. And then if you differentiate the whole function, which is capital F of root x, you are going to get small f of root x. So this is equal to f of x plus 1 over 2 root x f of square root of x. Sorry, I made a mistake here. So there must not be a negative value here. And therefore here is not, there's no negative here. And for that reason, this is negative. So remember that we said f of theta is equal to cos theta over theta. So f of x is going to be cos x over x minus 1 over 2 root x. Then f of root x is going to be cos root x divided by root x. So this is equal to, that is z of x equals cos x over x minus, now 1 over 2 root x times cos root x over x is 1 over 2x cos root x. So at the end of the day, we can factorize 1 over x out. So z of x equals 1 over x, then bracket open, which is cos x minus cos root x over 2. So this is the final answer. If x sine pi x equals integral of 0 to x squared of f of t dt, where f is a continuous function, find f of 4. So the equation is x sine pi x equals integral from 0 to x squared of f of t dt. So let's take the derivative of both sides. So we are going to find d dx of x sine pi x equals d dx of integral of 0 to x squared of f of t dt. So now you see that this is product of two functions. So you keep x constant, then you differentiate sine pi x. So you are going to get pi and then cos pi x. Then you add the two. You keep sine pi x constant, then you differentiate x. If you differentiate x, you get 1. So to be plus sine pi x. And this is equal to, now remember that if you integrate small f of t, you are going to get d dx of capital F of t according to fundamental theorem of calculus, evaluated at 0 and then x squared. So let's continue from here. So at the end of the day, this is going to be pi x cos pi x, cos pi x plus sine pi x equals d dx of, now f of x squared and minus capital F of 0. So now pi x cos pi x plus sine pi x equals, if you differentiate capital F of x squared, you need to first differentiate what is inside the bracket. And if you differentiate x squared, you will get 2x. And if you differentiate capital F of x squared, you get small f of x squared. Then now if you insert 0 into the function, you are going to get the, so you see that here is d dx of f of 0, which is a constant. If you differentiate a constant, you get 0. So that part goes off to 0. So now let's make f of x squared the subject. So f of x squared is equal to 1 over 2x, bracket open, pi x cos pi x, then plus sine pi x. But the question says we should find f of 4. To get 4 here, we need to insert 2 because 2 squared is 4. So f of 2 squared is equal to 1 over, wherever we see x, we insert 2 in that equation. So it's going to give us 1 over 2 times 2, then bracket open. Now x is here, which is 2 pi cos, then pi x, which is 2 pi, then plus sine 2 pi, bracket close. So f of 4 is equal to 1 over 2 times 2 is 1 over 4, then 2 pi. Now cos 2 pi is 1, then sine 2 pi is 0, so plus 0. So at the end of the day, we are going to get 1 over 4 times 2 pi, which is equal to pi over 2. And therefore, f of 4 is equal to pi over 2.